In this section of notes, we're going to look at one more type of spread and also one more type of data display for quantitative data. So in previous sections of notes, we've talked about dot plots, stem plots, and histograms. Today we're going to talk about box plots. And in previous sections of notes, we talked about standard deviation and variance. Today we're going to talk about IQR or interquartile range. Now, a lot of this may be review for you. So in order to find the IQR, it's another measure of center. You would first start by finding the median to split your data into two groups, the lower half and then the upper half. For the lower half, you find the middle of that, or the median of that, and that gives you Q1, or the first quartile. And then you repeat the same thing for the second half of data, and that gives you Q3, or the third quartile. And then you take those two values, Q3 minus Q1, and that gives you the interquartile range, or your IQR. So here's an example. We looked at these 20 New Yorkers and how long it took them to get to work each day. So we'll do this same kind of setup again. We're going to start by putting the numbers in order from smallest to largest. There's an even number of numbers, which means that there's two numbers in the middle. So to find the median, we find the average of the 20 and the 25. When there's an even number of numbers like this, the first number, so the 20, that gets counted with the lower half. So there's 10 numbers in the lower half when you go to find your Q1. And the second number, the 25, that goes with the second half. So the 25 goes with the second half when you go to find your Q3. So that gives us the calculations we need to find our IQR. So we do Q3 minus Q1 to get our IQR. Now, in terms of what the IQR gives you, it gives you the range of the middle 50% of the data. So you might remember range from a previous course. Remember, range is the largest number minus the smallest number. So for this set of data, the range would be 85 minus 5, which would be 80. And then the IQR gives you the range of the middle half of the data. So the 10 values in the middle have a range of 42.5 minus 15, which is 27.5. So in a previous section of notes, we said that when you describe a distribution, you have to address 4 things. And so far, we've addressed 3 of those 4. We've addressed shape, being either symmetric or skewed. We've talked about center, either mean or median. We've talked about the spread or the variability, either being standard deviation or IQR. And the one we haven't talked about yet is outliers. So an outlier, in general, is just a number that's too big or too small. It's much bigger than all the other data values, or it's much smaller than all the other data values, but it has an actual formula. So if it is more than 1.5 times the IQR away from either the first or third quartile, that makes it an outlier. So for our problem where we were talking about the commuters, where we had our Q1 as 15, our Q3 as 42.5, and our IQR of 27.5. What we're going to do is we're going to take our IQR and we're going to multiply it by 1.5. So any value that is more than 41.25 away from either Q1 or Q3 would be an outlier. So we do Q1 minus 1.5 times the IQR, and then we do Q3 plus 1.5 times the IQR. And this kind of gives us what we call like our cutoff values. Any value in our list that would be smaller than negative 26.25 would be a small outlier. And any number that would be bigger than 83.75 would be a large outlier. Some groups have no outliers. Some groups only have small or large outliers. Some groups have both. Sometimes there's more than one small outlier or more than one large outlier. So those are all options. So if we go back and look at our list of numbers, our smallest number was 5. That's not smaller than negative 26.25, so there's no small outlier. But our biggest number was 85, and that is bigger than 83.75. Now our second largest number is 65. That's not an outlier. It's not bigger than 83.75. So we do have one outlier at 85. So next up, we're going to start moving towards how we would go about making our box plot. In order to make a box plot, we need to know our 5-number summary. Our 5-number summary is the minimum, the maximum, and then the 3 numbers we've already found so far, the median, the Q1, and the Q3. When we go to make our box plot, also known as a box and whisker plot, we make vertical lines to make the box part involving Q1, the median, and Q3. And then we make our whiskers, or 2 lines that extend out of that box in the middle, that goes to the minimum and the maximum. That's if there's no outliers. If there's an outlier, then we put a little star or an asterisk at the outlier, and then our whisker just goes out to the next biggest or the next smallest number that's not an outlier. So for the numbers that we've looked at in this last example, so the commuter times for New York, recall what our numbers were. So we had our median, our Q1, and our Q3. We had our minimum, we had our maximum. Now we did remember that our maximum was an outlier. So our Q1, median, Q3, that makes up the edges of our box. Our minimum was 5, so that makes up the edge of the whisker. However, the biggest number on our list that's not an outlier is 65, so our whisker only goes up to 65. And then we put an asterisk or a star at the outlier of 85. So there might be more than one asterisk in your box plot if there's more than one outlier.